how many records are in the system for prescriptions. And in this case, we have 5, so there's 5 prescriptions in the system. The min and max do not include null values for the purposes of minning or maxing. So a null value is neither a min nor a max. You're not going to get that. And so a null value is neither a min nor a max. You're not going to get that. And the arithmetic mean is your average, so it's AVG. It's not the word average, it's just AVG. In SQL Server, it may be different in other DBMSs. And so what we've done here is we've done select max drug price from our clinic drug. And so our most expensive drug in this system is $124. You can see how we've done that mathematical operation on going through all of the records that were there and coming up with the maximum value. You could do the same thing for the min. What's the lowest price drug that we have? And then sum, of course, is all of the numbers added together. You can use sum, and in fact, we will be using sum a lot in calculating what is the total value of an item, how many items are in line items for an invoice, that kind of a thing. You can add all of those together. So these are the 5 basic aggregate functions that you're going to be using on your data. With date times, just a heads up, min and max, min is younger, older is smaller, or min is smaller, it's older. So you're looking at it as starting from date, say January 1st, 1900 is the min, going up to wherever we are now is the max or older, or in the future. So in the past is min, in the future is max. As long as you keep that straight in your head as to what that means by min and max for the purposes. And that gives you some basic information on aggregate processing. Let's talk about how we're going to use that with a little bit more detail. So our next slide is going to be our grouping data. When we have data that we want to do an aggregate function on, usually we don't want to do it on the entire record set. We don't want to do everything in the entire database. We really only want it grouped by certain things. In this example, what we've done is giving you a list of all of the customers, and then I want to break them down by what is the total balance per area code, because I want to be able to split it into 2 different sections. If I had cities here, I would have done city. So for each of the different cities, what is the customer balance? You could do something similar like that with different types of customers, grouping by who their manager is, who their agent is, something along those kind of lines. So what we've done here is we have included 2 fields. Instead of just having the star to do all of the fields, we have selected 2 different fields. We've selected the area code and that customer balance. And we're calling the function sum, which is our aggregate, on customer balance. The important thing with grouping aggregate data is remembering if you have a field in your select statement that does not have an aggregate function on it, it needs to be included in your group by. So in other words, I can't have the area code in this select function with because to aggregate an entire record set, we have to know where the groupings are. So the way that we would use this, so if we said something like for each patient, when was your last prescription? I could say what was the max date in the prescription table based on each customer code or something along those lines. So grouping by customer code. You can group by multiple fields. In fact, you will have to group by multiple fields in the situation where you need to be able to have more data than just the area code. If I wanted to have some other piece of information in here. We're going to talk about subqueries in a few minutes, which will allow you to get this piece of information and then be able to use it in a future query. But for the purposes of just grouping your data either has to be included in an aggregate function or it has to be a group by. And by the way, I've thrown up in the top corner the select field list from where, so that you know where the group by goes in your query when you're writing it. It goes between the where and the order by field. And this is, so if we're doing our select query, we're always going to start with our select, After our select, we're going to go to our from. If we had where criteria, we would put them in where the where clause is. We do not need where criteria. As you see, the examples I gave you didn't have where criteria. And then we have our group by and then our order by if we want to. Remember, order by is also optional. You do not have to have an order by field or a where clause, and that's fine. One of the little things to keep in mind is that distinct keyword. If you start working with this and you find yourself with duplicate data, which you shouldn't have if you're grouping by, remember that distinct keyword. It's going to come up a couple more times in this section of the code and then, of course, in your homework. So just keep in mind that distinct to be able to remove any duplicate values. You don't want to have duplicate values if you don't need them. So you want to throw in that distinct and it'll return or remove any duplicate values. All right. With our grouping data, we have a clause called having. And the having clause is very, very similar to our where clause in that it will restrict or qualify your group of data based on your aggregate function. The difference between a where and a having is that a where is applied to the column data itself before the select statement has even occurred. So we go a from, we go a where, then we go to the select. When we add in aggregate functions, the having clause applies after the select and the group by. So it has already done your group by and your aggregate before it gets to having. This allows you to apply criteria directly to the results of your aggregate function. So you've written your aggregate function saying, I want to know what the average price was. And in this case, I am able to take that average price and be able to put it into a where clause, which we're calling having. So the having clause to allow us to use to restrict that. So in this case, I'm giving you all three queries. First is all of the products that exist in the system. The second query is the aggregate, getting the average and the count. So we have our average price and our number of products that exist with that code, where we're grouping by the code. So that vendor code, the ones that are done by a specific vendor code. And then we are going to do the having clause. Now, when I write this, when you write your queries, what I recommend you do is you do all three queries separate. So if you have things that are kind of like, okay, I'm going to start with my products, and then I want to find the average, you can still do a select star when you're just looking at your products, but obviously once you start throwing your aggregates, you need to start connecting your fields. So throwing your aggregates on the second query, getting that all right. Then you look at your result set and say, okay, I've got the code, I've got the average price, I've got the number of products. Now I think I want to go ahead and do where the average price is less than 10. So in this case, there's only two. The 21225 and the 21231. Those are the only two that are below $10 for their average price. I can throw in my having clause at this point. The answer to this query is just the last one. The first two queries don't matter. But while you're building it, you may want to look at those just because they'll give you information. They'll let you see your data and recognize, am I getting the right data in the right place? A lot of times when you're writing queries, if you don't do this kind of breaking out your subqueries, breaking out things into different little sections, you may miss something. You may look at it and go, well, look, there was some data on there that had a vendor code of null. Maybe I needed to deal with those. Why were there nulls in there? Why do they have no vendor? Maybe I need to answer that. But if you don't look at all of your data ahead of time, you may not catch that. Okay. All right. The next thing that we want to work with is our subqueries. Now, our subqueries can return multiple objects. We can have a subquery that returns a single value. You can have a subquery that returns an entire record set that you can use as a join in your from clause. And you can have a subquery that returns a record set that can be used in other things in that set. So this one is the one that is a subquery that exists in a from clause. So you can see in the little notation I have up in the top corner, this is the subquery inside of a from is going to return a record set that you can use with a join. In this case, what I have done is I have created a subquery in between the parentheses that is going to get me the total of the invoice and the total number of items in my invoice. So remember when we have line items in an invoice, and this is in the store company, something like that, query that you can go look at. The ERD is in your book as well. So if I have this and I want to get all of the items, line items, and I want to figure out how many line items there are in total. So they got 3 hammers and they got 4 screwdrivers for a total of 7 items. So that'll be my sum of my line units. And then I want to have the price. So I want to sum together each of the individual line prices and add all of those together to get the total for the invoice. Because I don't care about each of the individual items. I just want to know how many physical items am I putting in the box and what is the total for the whole invoice. That's all I care about this point. So what I want to do is I want to get the customer code, the invoice date, and the invoice number. And then I want to get the sum of the invoice total, or the sum of the line prices and the sum of the line units to make the invoice total and the total items. So I'm going to make this query. So what I would do first is I would actually write everything that is inside the parentheses, starting from the select customer code all the way down to the group by. I would write all of that separately, and I would make sure that that was the query that I really want on my inside of my inner join. Once I've written all of that, I can put it inside parentheses. Make sure you give it an alias so you can refer to it. So you can see I've said as invoice here, or INV, as my alias. And now I can just do a regular inner join just as though it were 2 tables that I could access. And so I can do my inner join on my customer code, and I can get the data that I want. What I have here is that Leona has 3 invoices, one's for $5, one's for $15, and one's for $137 for a total of 2 plus 5 plus 9 items. And I can see what date she did those invoices, and I can see the invoice numbers. Because I was able to do this inner join by connecting it to my customer here, it made it very easy for me to get the customer information that I need, because I need her phone number so I can call her and confirm that she got her items or whatever it is. Put it on there somehow as information in that invoice. So I have them ordered by last name because I want to have all of the people last names ordered. I could also order by invoice or by customer number to make sure all the same customers are all together. I could, by the way, group this, throw in an extra aggregate and say how many invoices did Leanna do and what was the total invoice and how many total items did she get. So I could aggregate the invoice total and the total items and the invoice numbers to get that as well if I wanted to. In this case, I don't care, so I don't need that. When we talk about subqueries in this context where it returns an entire record set, it returns like a table or what we call a view. A subquery is simply a select square statement that is inside of another query. I always will put parentheses like this to help me visualize that is my subquery. I will always line up my items where I have my select and my from and my group by and my inner join and anything else. Unless I can get, like, if it's just a really simple one, select star from or something easy like that, I may keep that in one line, but I will try to line these up as much as possible to make it very visually clear to me that this is my subquery. Unfortunately, the as and the select and the from are all color-coded by making them blue, so that makes things a little easier as well. In this case, we talk about the outer query versus the inner query. The inner query is my subquery, and my outer query is the one on the outside. You can nest subqueries. You can have multiple subqueries inside of subqueries. However, you need to be careful about those because every subquery you do is going to increase, in some sense, your processing time because you have to go get the subquery, return it, and then continue on with your processing. You can, of course, have your inner query return a single value, a list of values, or record set. And you can throw where clauses in here. You can control what's going in there. You can have your having clause. I only want to have, in this case, invoices that are over $100. If that was something that I wanted to do. And I can include that in my subquery. Once my subquery is done, join to get customer information. This is your basic subquery that returns a record set. The next type of subqueries that we're going to talk about are ones that use the in operator. Remember we talked about this at the beginning of SQL queries so that you could use an in your where clause. In your where clause, you could say where a value or a field name is in, and then a list. So we could remember when we did all of the female people, we could say where it's Mrs. or Ms. Having those inside of a list. In this case, you can do that. The list that you're picking is a record set of values from a subquery. So we can use our subquery to create that list. The example that I've given you here, and I haven't given you the actual result values, but I think you can kind of figure it out. First thing I did was I looked at what is the vendor code for my specific vendor. So I'm going to select the vendor code where the name is Gomez Brothers. And that's going to return all of the products that I have that are by this vendor. If I know the vendor ID right off, I could just say where the vendor code equals the ID. But if I wanted to do this where it was all of the vendors that are in Great Falls, and I wanted to limit it at that case, then the where clause would make a little bit more sense. I could do where city equals Great Falls, and that would limit me to a list of vendor codes. Now I'm going to select all of the products that have one of those vendor codes. So I'm going to use the in clause, or the in operator, where the code is in, and then with parentheses I have my subquery. Once I get that, I can make my nested subquery, which is the bigger one over on the right-hand side, where I want to say, give me all of the information from the invoice and the line items where my product code is in the product where my vendor code is from Gomez Brothers. So this way I've been able to use two subqueries to be able to use the in clause twice, both all of the products with a vendor that's in this group and all of the invoices that have a product code that is in this group. So same concept as using the in that we did with the where clause before. We're still using the where clause, we're still using the in operator, but instead of putting in a list with brackets, we are actually using a subquery to populate that list. Make sure when you do it this way, if I am going to say where the P code is in a list, make sure that the list that you give them is a list of P codes and not a full query with a lot of different fields. I just want the field's P code. So you'll notice that here I said select just the P code from product where all of this other stuff happened, because all I want this record set to be is a single list of one field called product code, and that's what I want to check to see if it's in. In this case, we are doing the where clause with our subquery, so you can see up at the top corner where I put in the where and it's field in subquery. I should have bolded it too, but that's okay. Okay, one more type of subquery. Correlated subqueries are similar to nested loops. Remember when we did our programming and we had 4 hours from 0 to 24 and 4 minutes from 0 to 60 and 4 seconds from 0 to 60, and then we were able to take values from all 3 of those and print them all in the same value? When we do correlated subqueries, we are using pieces of information from our outer query inside our inner query. So in this case, the example that I've given over on the right-hand side is the line number, which we have labeled as LS. We've aliased that as LS. And we are getting the P code from the line number, and then we're figuring out the average for that P code every time that we run this where clause. This, by the way, is an expensive query. So this query takes a little bit more effort than a simpler query, because what we're doing is we're recalculating that subquery every line that we're going through in our outer query. As opposed to just creating the query once and being able to use that multiple times, we have to recreate that query each line, which is fine because that's actually what we want to do in this case. We want to make sure that for every a product code, we are counting what is the average of the line units for that product code, and then we're going to compare that. So we only want line items where it is higher than the average count. So in this case, we are using the piece of information from our outer query inside of our inner query, inside of our subquery. There is also the concept of an exists keyword, and the exists keyword compares if the subquery returned anything. Now, I can still do that correlated subquery when I do this so that I'm using my my vendor V code, my vendor code from my outer query in my inner query, and I just want to see if any results came back at all. This is just checking to see if the quantity on hand is less than the minimum times 2. How many quantity on hand do you have, and do we have the right amount for whatever it is we're calculating? But the exists keyword will simply say, yes, a value, at least 1, came back from this subquery. As you can see, this subquery, I was able to do a select star because I don't care what came back. I just want to know if there were any records or if there were not any records. So I don't care about individual field names. I could put in just like select product code from product if I wanted to just put a single value in there. Or I could put the star. It doesn't matter because it's just returning whether or not a record returned rather than individual records. So these are correlated subqueries. They are subqueries where your outer query values are used within your inner query. All right, the last section of this grouping of chapter 7 is going to get into SQL functions. You've already done SQL functions. We've done a couple of them. Definitely we did the date one with the date difference. So you can kind of see how SQL functions work. We use our functions both inside of our select statements and inside of our where criteria. So if I was going to say get date or a date add, I can put those inside of my select statement. I can also put them in my where clause, and I can also actually put them in my having clause as well. So I can put them in a couple of different places to allow me to do a calculation or a function. In the book, they list out a lot of them, the useful ones, the ones that a lot of people are going to use. But they separate them by DBMS, and that's intentional because depending on which DBMS you're using, sometimes they don't use them exactly the same, and sometimes they have a little bit of different terminology or syntax. So for the purposes of this course, we're looking mostly at the SQL Server versions, but I would like you to glance at least the Oracle and the MySQL ones as well, just to kind of see how they're different. I think it's important for you to recognize the differences as well as the similarities between the different DBMSs. So the book will break it into 4 different types. We have our date time functions, which is like our converts, convert a string to a date, our get date, which just gets now, and our adding and difference. It also has the month, day, year type functions that you can do to just get the month number. We have numeric functions like absolute value or round. Round is a really useful one that I think you're going to use on your homework to make sure that you only return 2 decimal places. Because when we start getting into calculations, you're going to getting floating point numbers. Floating point numbers can go off forever, and they're annoying, and they're ugly, and I don't like them. So you're going to round some of those just to be able to understand you can do that. You can round your results, and you can use ceilings and floors. Remember, ceilings will get you the next highest, the next So you're in between 2 integers. Ceiling will get you the next integer up. Floor will get you the previous integer down. We have string functions like uppercase and lowercase. Substring is useful if you need to break out any piece of your string so that you only get certain pieces of information. And then, of course, concatenation, which you can also use the plus sign to concatenate. The last one is going to be on conversion or casting. There's also a concept called casing the switch, which is similar to a switch statement in
Can fucking wait.
in code where you can say, if the case is this, then go do this. If the case is this, then go do this. So I could say, if my type was A, then get me everybody over $100. If my type is B, then get me everybody over $50. If my type is C, get me everybody over $20. So I can check based on a piece of information for your case and switch options. And those are available in SQL Server along with Oracle and MySQL as well. So just a little bit different in the way that they are syntacted. Okay, so that is the gist of 7.7 through 7.9. I'm giving you a lot of homework on this. And I recognize that it's a lot of homework, but I think at this point we've done enough SQL statements that you're going to be okay with this. So there's a total of 27 queries, which sounds like a lot, but I went through, looked at every single one of them. I would say there's somewhere between 5, maybe 5 to 10 that are complicated. A lot of them are simple. Go get all of the employees and print out their first name and last name. You've done this. So a lot of the queries in the homework are going to be things that you've kind of done similar together. The ERD is included. I have it right here on the screen, but it's also included in the book on page 331. So look at the ERD, understand
use the powers of your mind.
Do not want to fight you, comrade. I don't want to fight you either. I want you to fight for me.
I'm going to play with it. Get her out of here.
Are you crazy? That thing will kill you.
He's right, it's magic. So am I.
Use the powers of your mind.
Your team is banding.
cut mine. What you just did? I think you want me to cut your hair. I want these braids. You want those braids? Those braids. We can go beard for beard, or we can go M for M. What you want to do? Yeah, man. R. Kelly, better go sit down somewhere, because I'm the real R. Kelly. If you don't know how to braid, hit that follow button. Let's go! Ooh, I'm like friends, man. How you feeling, man? Man, you know, well, you are the best, man.
Reaches the battlefield. Smash them! All troops deployed!
The strongest ninja has arrived. I'd give up on anything for the ultimate ninjutsu. Anything. Ha!
Slain.
Face the demon. dead! Feel the wrath.
Killing spree. An enemy has been slain.
Out of my way or get torn to pieces! Will devour all. Behold!
An ally has slain the turtle.
No one spared.
Ult is ready.
I will devour them, limbs first. I give them up anything for the ultimate ninjutsu. Anything. I dead.
Team destroyed.
Let the bodies pile up.
Killing spree.
Do you like this one, Hanigage? They will die. Attack the turtle. Watch out for the jungle. All of this is to make myself
Initiate retreat. Ult is not ready.
dead. Watch out for the jungle. Rest in peace.
Ult is ready. Ally has been slain.
Sacrifice your soul.
Bloodbath.
Flesh.
Double kill.
Rest in peace. Don't be afraid. Right there. We will lose again. Hame no Habakiri will devour all. Ninjutsu Sankaichi Detaizen! Die!
An enemy has been slain. Ally has been slain. Carry.
The thirst for power won't die. out of your mouth. Die.
Our turret has been destroyed. Our turret is under attack.
Will devour all.
Our turret has been destroyed. Monster kill. Destroy the turret. Shut down. Ally has been slain. Shut down. Legendary. Slain.
They will die begging for mercy. Face the demon.
Request battle. An enemy has been
Understood.
slain.
Don't be afraid. I'll be your last nightmare.
Under attack. Request battle. Killing spree. Inhibitor turret is under attack. Destroyed. Request backup. Our base is under attack. Enemy slain. An enemy has been slain.
Even hell trembles before me. I'm dead.
Slain an enemy.
Rest in peace.
Killing spree. Launch attack.
Sacrifice your soul or your flesh. Or both.
Enemy double kill. An enemy has been slain. Enemy triple kill. Double kill. Under attack. Our request backup.
I'm dead.
Understood.
I will devour them. Limbs first, then torso.
Slain.
The wrath.
Ally has ult is not ready. Your turret is under attack. Good game. Battle scout ready.
All of this is to make myself stronger. They will die faithful.
An enemy has been slain. Shut down. Initiate retreat.
Don't be afraid. I'll be your last nightmare. Hame no Hamakiri will devour all.
Ult
Face
is
the
ready.
demon.
Let's try again.
Launch attack.
Understood.
The enemy has slain Lord. Initiate retreat.
Understood.
Initiate retreat. Ally has been slain. Initiate retreat.
The Supreme Ninja is
Ult
back.
is ready. An enemy has been slain. Request backup. Slain an enemy. Ult is ready.
Let the bodies pile up.
Request backup.
All of this is to make myself stronger.
An enemy has been slain. Request backup.
Sacrifice your soul.
Down. Ult is not ready. Kill. Shut down. Triple kill.